Good day, Tarl. It's good to have you here with us. Something that's been coming for quite a while. We've been tasked to have a chat to you. And we've got Tarl Berry here from CRI. Tarl, I think from your side, introduce yourself for the people that don't know you. What do you do at CRI?
Yeah, so my name is obviously Tarl Berry. I was hired probably 5-6 years ago by CRI. So they positioned me in Stellenbosch University. And I work on the cold chain. So I'm the cold chain researcher. With the mandate basically to just optimize the whole cold chain process, maximize quality, try and help the growers get the fruit out, optimally while still managing these market access requirements, which are the big issue for us.
That's such an important part. It's really, really vital. I would imagine that you are seeing a wide range of issues along the way.
But why? Okay, yes, it isn't. But I think tell us why the cold chain is so important.
Yeah, no, I mean it's obviously South Africa is positioned extremely far from its markets. We're servicing the northern hemisphere predominantly, and we're in an unusual position. So basically, our shipments can take up to 30 days, 50 days sometimes. The industry itself is growing like rapidly, which I think we all know. But basically, we're constantly, at least for my period, the last 6 years, just continuously under a dynamic change of requirements, of facilities to do sort of implement the cold chain. Everything is just changing. It's always in turmoil, and the industry's just been adapting continuously. I think the interesting thing is just most of the research out there is all for kind of climacteric fruits, a fruit that kind of go through a sudden spike in respiration, and their biggest issue is just over ripening the fruit, and citrus don't have that issue. So our niche, our market sort of problem is actually completely unique. There's no publication to support us. There's no resources. It's an open book actually.
Goodness, didn't know that. That's very interesting.
Yes.
So you kind of, I don't want to say making it up as you go along, but there's nothing. You are doing the seminal research to begin with.
Yeah,
most of the stuff.
It's really exciting position. I was excited to take it up. It's very rare where you can do research and then it's implementable. You integrate it. You're getting feedback as you work with the people, and then you're actually building sort of a new data set, a new book actually. So it's really been a privileged position and opportunity. So I'm loving it. Yeah.
So, from all of this stuff based on climacteric fruit being put into cold storage and cooling containers and things like that, what's been one of the most eye-opening things that you've found with citrus versus other fruit types?
Yeah. So I mean, when I was hired, they said to me the biggest issue was market access, and we just want to, we want to manage the fruit best to reduce chilling injury incidents, because that's our biggest issue.
Yes.
Citrus is really tough, but it doesn't handle the cold well. But we have to induce these sort of low temperature environments. Like I said, there was just no information. So the first step was just characterizing everything. So I think basically first we had to build tools to characterize, actually like physically build wind tunnels, develop systems to actually quantify things, because we wanted to know how much sort of resistance does a real pallet offer to airflow. We needed to understand how airflow moves in cold rooms, in containers. How does that impact?
How do you see that? Because you can't see, you can feel the wind, but you can't see it.
Yeah.
Do you smoke or?
No. So we rely heavily actually on like basically space grade technology. There's lots of resources out there. Sort of aeronautical research, mechanical engineering, that they rely heavily on CFD, computational fluid dynamics. There are a lot of sophisticated, expensive techniques. We've been leveraging. So we partnered with some people in Stellenbosch University. They've got a long record of aeronautical research. Some people in Switzerland, a little bit of Netherlands, and we just we use all the tools we can get. So usually the approach is just to try and model an environment with CFD, and then validate it, and that's really the big thing, because anybody can do a model, but not everybody can prove that it's working. And that's actually been the big foundation block of what we've been doing for the last 4 years or so, is just to validate the model and then start implementing and using it to give outputs to the growers.
Incredible. Wow.
If you walk into a packhouse now or an orchard with a grower and you say to them, do you know that CRI is employing space grade technology to make sure that your stuff is cooled properly? I don't think they know that.
No, they would have difficulty. Okay, what we do need to focus on the content of your presentation that you've done at the workshop.
So tell us about that.
So
unfortunately, we missed it, so it's a good opportunity for.
The fact that we missed it, unfortunately, we couldn't. But so you literally, please do a rerun on that.
Sure.
You don't have to rerun it, but just give us the.
Yeah.
Yeah. So I mean, as I said, somebody actually made a comment to me now. They said I didn't focus a lot on, the hot spots of the container, optimizing these protocols. But really, I think the last few years, the big issues has been chilling injury, because our protocols work, but they're harsh. And like I said, the big issue is just heavy chilling injury and sporadic. For the last 2 years, I think, we've been building wind tunnels mainly. But as you said, now it's really complex. How do you measure and validate these tunnels? It's tricky. But we managed it. So now we have kind of cold rooms, wind tunnels inside them. We've been sending students out from the University of Stellenbosch, and they're measuring in cold rooms, trying to get exactly, how do things develop, or what do they look like? What are the pressure drops across these pallets? And then we've been implementing sort of protocol tests on the fruit themselves, and then doing a full sort of shipping simulation. So now we have really nice data that I'm quite excited about, just showing that just 3 days of handling in a cold room drastically influences its susceptibility to chilling injury. So it doesn't actually cause chilling injury. The chilling injury is induced during the shipping process, but its impact on that response is massive.
Okay.
We're talking sort of changes of 80% more. So you will, get 2% injury, and if you do it wrong, you can get, 80% injury. It's massive. Wow. So we're really excited about that, and we have really good control over the cold rooms. So ability to mitigate injury there is a big benefit versus trying to fix everything in every other position.
So let me just see if I understand this correctly. If, let's say, fruit goes into a cold room let's say it comes from the farm or wherever, and it's got to stay there for either cold sterilization or whatever protocol to whatever country it is. If it doesn't get treated 100% there, the susceptibility to cold burn or injury in transit in a container is much higher.
Yeah, correct. Yeah, It's obviously, the complexities expand because, you get more susceptible varieties, though there's also exposure events that seem to make some fruit more susceptible to chilling injury already pre-harvest, post-harvest, and then now there's this additional variable in the cold room. So it's all these sort of accumulating factors that are really difficult to read, that are kind of landing in a result 4 or 5 weeks later at the market. So it's getting difficult. That I think is really the crux of a lot of the research, is just trying to pull these little components apart and then proving how they interact and what works and what doesn't work.
So if you say something that's pre-harvest, that's meaning the fruit is still sitting on the tree.
On the tree, yeah.
So it doesn't have to be accurate, but what would an event be kind of that could accelerate it in a container?
Give us a scenario.
Yeah.
I think it's known that like small fruit, fruit that were sort of stressed a little bit on the pre-harvest side, weaker rinds, they're and then again like a very sort of fragile variety are way more susceptible.
Okay.
And I think usually it's known, but to a large extent everything is run down the full pipeline. So especially in peak season, there's just very few options in a cold store. They just they send it down the mill, and people are doing a good job, but they just do the best they can. So now you maybe have like an issue that's cropped up early. It's a sensitive sort of product. It's moving down the chain, and then it gets kind of manhandled a little bit too hard in a cold room, and there was your opportunity to really mitigate massive risk for the next shipment phase.
So what could be done? What are the things to look out for in a cold room operating procedures in a cold room that could negatively affect the integrity of the fruit going forward.
Remember, that's also a separate entity controlling that. So it's not necessarily that is controlled by the farmer,
No,
the grower, or the
not at all.
exporter. So it's an entity that might,
It's somewhere else, and it's often an independent service provider.
and it's a commercial entity also. So
Yeah.
it's a volume-based thing. So they also need to.
Yeah.
I can't come to them and says you need to treat my fruit different than what you treat Tarl's fruit. So.
Yeah, I think that's the big mind shift that's happening now. Is a lot of cold stores are being built in anticipation of this growth that we've experienced and we're told to experience. And yeah, like you said, it's a service that's being provided. It's not kind of in-house like a packhouse is, your farm is. So it's really a relationship thing. And yeah, I think before cold stores were built and they were run, and things were done as they were done, and things were okay. But with these newish EU requirements and just the number of protocols, their options of doing stuff and how they implement cold treatment or cooling is just, it's limited. They can only do what they can do. And the grower or exporter, their ability to communicate with these service providers is not the same. Yeah. So it's a new kind of concept, like full transparency with the cold store, understanding the risks and having a discussion. This is something I think it's the next step really of just having this relationship and understanding where can we push barriers, because the big risk is you need to get the fruit out. We can't just leave it there and mess around with a like a really soft protocol. It has to be super efficient as well. So finding that middle ground is the big frontier at the moment.
But when fruit is in a cold storage facility, what are the things that could damage it? Is it extreme cold? Is it like stress, physical shaking damage when they move the stuff? Or what are the problems that can be created?
Yeah, the cool down rate, so how fast you're pulling them down.
Okay.
The airflow rates, so if it's in a forced cooling, how much airflow exposure is going through. The VPD, so the vapor pressure deficit.
What?
The vapor pressure deficit. So basically how dry.
Okay.
How dry.
How dry is the air?
How dry is the air around on the rind surface? How much moisture is it
Okay.
pulling out of that rind? And that's a factor of airflow and temperature and humidity. And each of those factors is obviously different. Even in a static room, we've definitely seen situations where there's a refrigeration unit on the top of the room, and it's kind of recirculating air in a certain region, and it does seem like that has an impact. So that generally we assume static rooms are better because they're kind of more stable, but actually, it's not so simple.
Interesting.
There's a lot of variables.
Is there anything that we haven't spoken about that you want to talk about?
Yeah, sure. So I mean, that's the cold store side,
Yeah.
which we're really trying to focus on now. Because this is, like I said, it's a really transition time. So there's opportunities now to optimize things dramatically. But I think a lot of the work is focused on container usage. Before we always use these special like SRV vessels, bulk bins, bulk pack or whatever.
Yes.
But the containers are the way forward, but everybody shares these containers. So it's servicing a global market, and we don't have a lot of opportunity or space to optimize the volume and the cooling there. So just optimizing packaging to use that environment efficiently. Floor covers to optimize how the airflow is distributed into the container. That's been a big focus.
Yeah, I think tell us about the floor covers, because when we met you the first time,
It was regarding that.
that we
And then things changed and all the rest, but it's a very interesting topic. So tell us
because
a bit more.
you get commercial things that you can cover floors with, which we've seen in containers being
Correct,
put in. But you guys have come up with quite a nice, simple design that can
That's
be done.
right. Yeah.
Tell us about that process.
Sure.
What happened?
Yeah, so I mean, there are a few sort of airflow optimization kits on the market. I think the big issue, when you got extremely high value products like grapes or berries or something with low volumes, some of these kits are really complicated. You can install them, but citrus is really it's a lot of product moving out, especially in peak. So I think the request was that we have introduce something that can fix the airflow and cooling and improve things, but that's very, very easy to implement. And you could it doesn't disrupt the process. So we tested, I think, probably, I don't know, about 100 designs on these sort of modeling software. And the one that really showed off was this, we called it the T floor. It looks like a T shape.
T for tall.
T for tall, or T for T, the shape. But yeah, and then we tested it commercially. We put it into containers, the NPE, and it worked really well. We have like kind of a, that was one of the things we also developed, is just a way to measure the airflow in a container. It's a huge volume, and to measure all the key areas, and yeah, just on those metrics, that T floor worked really well. It mitigates, it creates more of a uniform airflow distribution. The other thing we're concerned about in the container is just near the refrigeration unit, there's a big recirculation zone, very cold air, very higher airflow rates. That's where you're going to get most of your damage if you are moving towards sort of a chilling injury issue. And it sits right there, and it kind of redistributes the airflow away from that region back into the door region. So a nice tool to just help things a little bit.
So for the look, we're on video now. We don't have the actual thing here to demonstrate it. So for the people that don't know, is that your refrigeration unit sits right in the front of the container.
Correct.
And now you basically cover up the slats in the floor that is supposed to channel the air going towards the door at the back. You cover up a certain section right in the front.
Yeah. So the
and then
container
down
is
the middle.
12 meters, and it's about, I think, 400 mils sticking out with a long strip down the middle. So very little floor obstructed. That was the one thing we did find. A lot of these other floor covers cover a huge portion of the floor. And you can imagine if you put like a piece of paper over a fan, I mean, you just stop that air movement.
Yes.
And yeah, when we did measurements, I mean, a lot of the airflow is obstructed. So you really don't want to put a lot of obstructions over that floor. So this T floor, it just sits right at the door, as unobtrusive as possible, while still doing a little bit of good.
So listening to what you're saying, if you have this issue with the airflow in the container, you're going to have areas of the container, if you don't do anything about it, areas of the container that are potentially too cold, and areas that are potentially not getting enough airflow and could end up being a little bit warmer than they should be.
Yes.
So this is to mitigate that and to even out the uneven for airflow.
Yeah, so all our protocols are designed for the warmest regions of the container. So we always get the temperatures we want, but yeah, as I said, like near the refrigeration unit, lower down, those fruit are cooled to the extreme, and really it's just completely suboptimal in those regions. So, and the idea is just if we can just redistribute things more evenly, there's far less damage while still doing all the market access requirements that we need to do.
And this T-shaped device that you put on the ground, what is it made of?
The idea was to keep costs down, so you can actually make it out of anything. But we used liner board from cartons. So when they run these cartons, these carton corrugating systems, there's often huge reels of paper that they can't running in. It's a lot of energy to kind of use a loose piece. So there's lots of paper lying around, and we just use that.
And it's a one-time use from here to the destination, and then when it's disposable.
It's disposable, just like the cartons.
Okay.
Is it something that a grower can recreate on his?
Yeah.
When they, let's say it's somebody that's loading at the Packhouse, can they recreate it easily and cost effectively?
Correct. Yeah. So I mean, it's really, it's very easy to make. You can speak to one of the corrugators and just ask for some papers and just ask them to cut it. They've got all the equipment, and then there is now some people manufacturing it. I think it's EasyCo that have also made their own version. So it was designed by us, so it's open to anybody. But anybody can manufacture it and kind of provide a service to deliver it as a kit. So that is also an option now.
Tarl, what you've been telling us is absolutely fascinating, and this research is all being done in South Africa by South Africans.
Correct.
Has this sparked the interest of people elsewhere in the world?
So we've worked nicely with Switzerland. So we're doing some work with ETH there. They also have an interest kind of in supply chain, digital twinning, just how to manage sort of quality better over a large supply chain. So we're doing a lot of work with them, and just their research expertise and quality is just excellent. So it's always good to link yourself up with excellence, I would say. So
For
it
sure.
just pushes us up a little bit more.
And none of our competing countries, are they, I mean, does any of this kind of research exist there? Is there any collaboration or interest from their side?
I think there's some interest.
Of course, they'll be interested in what we
I'll
do.
be careful what I say now, but
Oh, yeah.
I think we're really on the frontier here.
This is where I'm
we have the
kind
toughest
of going.
situation. Yeah, we have the toughest situation, so it's understandable. But yeah, just that strong link of I mean, we're well published now as well. But just the fact that we're linked in and practical, that we actually are trying to apply these things and are applying it. Yeah, it's made us actually like one of the leaders now in this field. Yeah, so it's something for the citrus industry to be proud of.
Well done to the citrus industry and for you and your team to be implementing this.
We had a discussion with John Jones yesterday about, and it just happened
Packaging.
about packaging, and it just happened that a lot of the conversation went around the pallet. With these systems inside the containers, how important is your packaging and your pallets and palletizing the two together? How important is that to help with this whole scenario?
Yeah, I mean that was the first place we started. Just when trying to optimize these protocols, especially with the systems approach, where we're managing our own system. Yeah, like I think for example the A15C, we called it the S2. We just fixed the ventilation holes, optimized things. I mean, drastically improved vent hole alignment. I think ventilation was sort of about 0.5% of the total area, and it's now sitting at about 5% with this new design.
Jeez, wow.
And then that plugs in much better with the pallet base. Yeah, so there's a whole sort of design approach now that we're trying to push just to improve that alignment. Because if you have better ventilation, sort of lower porosities of these pallets inside the container, then the airflow just reaches much further. And really what we want is more just airflow recirculation in the system. Just get that warm air out and get it back and keep those VPDs low for damage resistance. And it's very important.
Yeah, I can just think that there might be guys sitting with 5 years with a stock of boxes that now had to go and reinvest in a new design, and that might I can see I would have been upset if it was my concern, but in the end, if it is so much more efficient, with 4.5% more efficient than what it was, it's a no-brainer. You're going to have
For sure.
much better fruit arriving.
For sure.
Yeah.
My goodness, it's incredibly interesting. So when you did your talk earlier, what was your sort of summary and conclusion? Do you want to share that with us?
Yeah, I think the biggest surprise we had last year was just also with the cold storage treatments. And we found that a preconditioning, so holding the fruit at about 10 degrees to 15 degrees for like 5 or 7 days, I was really surprised. Just that preconditioning step massively reduced chilling injury.
Oh wow!
Okay.
Yeah, we kind of picked it up on a old paper for Star Rubies, actually not Marsh, and we started testing it on our varieties, and just something. And I mean, 5 days is not a long time, but something is happening physiologically to that fruit, and it can just withstand the cooling a lot better. So we're looking forward to this year, just to push forward and try other alternative protocols. See what we can do.
How would a grower or packhouse implement something like that?
Yeah, for me, we had a discussion about just the cold stores are service industry. So I think a lot of cold stores are kind of sticking their head out and saying, like, we want to outperform. We want to offer a better solution, but bring the fruit to us. So I think it's something the cold stores need to offer and bring forward. And then, so if somebody's having an issue with chilling injury, everybody's getting chilling injury with these low shipping temperatures. The person that kind of offers the best solution for that is going to get all the fruit. So I think that's where it's going to go, and that's what the cold stores are doing. They're looking for these things. They want answers. Whoever implements it best will win out.
Okay, so again, if I understand correctly, so grower will pack the stuff. He will ship it to wherever his cold storage is. That it must undergo a cold treatment before it is loaded out. So technically, it would stand for 5 to 7 days, and then the cooling part will start, and then it gets loaded.
Yeah, so we tried a whole bunch of options. The trick with these tests is just how much fruit you need.
Yeah.
You need like a pallet of fruit. and then to evaluate everything. And everything must actually be simulated in the full supply chain to find these results. It's huge trials.
The best would be to have a full container. Ola.
Yeah, that would be the base. But you can imagine evaluating every fruit.
Exactly.
But yeah, we just wanted to test if you hold where you hold the fruit, because sometimes people will leave it in a room, in a cold room or a holding room or just outside. And we're curious, where you hold your fruit, does it matter? And holding it sort of, like I said, 10, 15 degrees before you put it into the pre-cooling cycle and then into shipping matters a lot. So 10 degrees, 15 degrees for 5 or so days.
So it's like a step down from
Yeah,
ambient
it's a
temperature,
softening
down a little bit, and then down
Yeah.
to...
And I think a lot of it has to do just with metabolically, it's still pretty active at 10 degrees, but it's sort of experiencing something. So I think it's just it has an opportunity to adjust to what's coming.
Fascinating.
So you can't do that. Keep it at 10, 15 degrees. Let's say that somebody's got a cold room, he's got access to a cold room close to his packhouse or at his packhouse, or he's planning to build one. You can't do that, then load it on a tot liner at ambient temperature, ship it to wherever it must go, and then go into cold.
Yeah, at the moment, that's against all the recommendations. You don't want to break the cold chain.
Yes.
But yeah, some people. I was actually asked this question twice. Some people have a lot of cold room facilities, so yeah, the question is, maybe they should. Yeah, we will test all these things, but at the moment, the recommendation, don't break a cold chain, because you don't want to make the food cold and then you got all this moisture loss problems.
Exactly.
Okay. Well, it sounds like you're busy with some incredibly interesting stuff, and I do think we'll probably need to chat to you again sometime. But thank you so much for sharing it, and I think it's very valuable information.
So with you working in all the cold rooms, you must have, these hot days must be terrible for you.
Yeah, that is the one upside. Unfortunately, it's a winter season. Huh?
Yeah.
Yeah.
Thanks so much, Tarl. Thanks for joining us.
Thank you for the work you're doing. It's
Thank you for this.
it's a incredibly valuable part of the chain. Thank you.
Thanks.